Good morning students. Thank you very much students for clicking on my video. I'm your Nagini ma'am, chemistry mentor. In today's section I'm giving the best tricks to remember geometry, shape of the molecules. Okay, now this topic is from the chemical bonding lesson 11th class first PUC students. In the previous videos I discussed you how to find the hybridization and how to find number of bond pairs, number of lone pairs, and second model also I discussed you hybridization how to find. That is the second video students. Once you go through that, in this video I'm directly calculating the bond pairs and lone pairs. After that hybridization also directly I'm going to calculate shape, geometry. Okay, now that mainly I'm going to discuss about these two students, shape, geometry. Are you clear? Because this is a very important topic for the competitive exam students. Okay, just one molecule they will give you. What is the shape of the molecule or what is the geometry of the molecule, they may ask you. So many students are confusing which shape is the correct, which one is you have to write. Students have they have more confusion in that to write the shape and geometry students. So that's why I'm giving the best trick students to remember the shape and geometry. Okay, now if suppose lone pairs of electrons absent, then according to hybridization those shapes are fixed students. Okay, now if suppose lone pairs of electrons are present in the molecule, then according to the Vesper theory you have to follow the shape students. Understanding? Because whenever lone pair of electrons are there, according to Vesper theory students, lone pair repulsions greater than lone pair bond pair repulsions greater than bond pair repulsions. Are you understanding? Repulsions are more. Okay, nama, that is according to Vesper theory. Okay, nama. So that means if lone pairs of electrons are absent, according to the hybridization shapes are fixed. Are you clear? Shapes fixed students. Now I will discuss you shapes, nana. According to the hybridization, according to Vesper theory, different shapes are there. Okay, now I am giving the hybrid shapes, nana. SP, what is the shape? SP2, what is the shape that I am going to discuss you first. If suppose two we are getting bond pairs plus lone pairs value, two value we got, then what is the hybridization? From 2 I'm going to start you. Okay, 2 sp hybridization. 2 means sp. Okay, that means what is the shape students? According to the hybridization, linear shape. Okay, now 3 means sp2. 3 means sp2, that is which shape students? Trigonal planar shape. Okay, now 4 electrons are there. Suppose 4 there, bond pairs plus lone pairs value 4 came. Then sp3 means tetrahedral shape, amma. These shapes are fixed, nana. Next 5 means sp3d means trigonal bipyramidal shape. Trigonal bipyramidal. Okay, pyramidal shape. Trigonal bipyramidal shape. 6 means sp3 D2 octahedral shape students. Octahedral. 7 means sp3 D3. This is pentagonal bipyramidal shape. Bipyramidal shape students. This table you have to remember. This is according to the hybridization topic, nana. Okay, na. So these shapes are fixed students. That means absence of lone pairs. If lone pair is absent, then this is the thing. Are you clear? Lone pair absent. Clear? Lone pair is absent students. Then you should follow these shapes. Very important. Lone pair is absent. Okay, if lone pair absent, then these shapes are fixed. Okay, if lone pair is present, according to Vesper theory, you have to follow the shapes. Okay, now one by one I will discuss you students. First example I am taking. Example 1. Example 1, BeCl2. First example, BeCl2. How many bond pairs students? 2 chlorines attached. This is the number, indicates the bond pairs. How many lone pairs? Beryllium valence electrons, 2 valence electrons, minus bond pairs, 2 minus 2, 0. Are you clear? 2 minus 2, 0 students. This how to find it. In the last video I discussed with students lone pairs, how to find the lone pairs and bond pairs. Once you go through that video, you can easily understand students. Okay, ma. Hybridization. Now hybridization means bond pairs plus lone pairs, 2 plus 0. We got here bond pairs plus lone pairs. How to find it? Bond pairs plus lone pairs. Bond pairs 2, 2 plus 0, lone pairs 0. 2 plus 0 means 2. 2 means which hybridization, students? Sp hybridization. Clear? This is Sp hybridization, students. Okay. Now what is the shape of my Sp? Here lone pair is absent kada? 0 na. So that's why what is the shape? Linear shape. Clear? What I told you, shape linear. So right here linear shape. Now what is the geometry? Beryllium chloride, here chlorine, here chlorine. This is the linear shape. Understood? Now I am discussing the second example. Second one, BCl3. Okay, BCl3. How many bond pairs, students? BP means bond pairs, Nana. LP means lone pairs. Bond pairs, 3 chlorines attached, 3 bond pairs. Are you understanding? Three bond pairs. How many lone pairs? Boron atom, how many valence electrons are there, students? In boron, 3 valence electrons, 1s2, 2s2, 2p1, 3 valence electrons minus bond pairs 3. So 3 minus 3, 0. Are you clear? Lone pairs, how to find it, students? Valence electrons minus bond pairs. This is the formula. Okay, now which valence electrons? So central atom, beryllium, boron, like that. Okay, 3 minus 3, 0. That means lone pairs is 0. Okay. Now hybridization, how to find it? Bond pairs plus lone pairs. Bond pairs 3, lone pairs 0. 3 plus 0, 3. 3 means which hybridization I told you? Sp2 hybridization. Sp2 hybridization, which shape, students? Which shape I told you? Trigonal planar shape. Clear? Trigonal planar shape, because here lone pair is absent kada. Lone pair is absent, so that's why according, if lone pair is absent, this shape is fixed. Trigonal planar shape. So write that one, trigonal planar. Now coming to the geometry, students, what is the geometry shape? Now coming to the BCl3, students, trigonal planar, B chlorine, chlorine, chlorine. This is the BCl3 geometry. Are you clear? This is the trigonal planar shape. Okay. Now see, students, third example. Third one, methane, CH4 I am taking. Okay. Sp hybridization completed, students. Sp2, here 0 lone pairs completed. Now I am taking the Sp2 hybridization only. Sp2, 1 lone pair is present. Suppose I am taking the example Sp2 hybridization, 1 lone pair. Okay, SO2 I am taking example SO2. How many bond pairs, students? 2 oxygens are attached, so that's why here bond pairs are 2. And how many lone pairs, students? Sulfur valence electron 6. So 6 minus bond pairs 2. But in the case of oxygen, you have to take double the number. So 2 2s are 4. Bond pairs you have to multiply with 2. 6 minus 4, 2 electrons. This is also I discussed in the last video, students. Please once you go through that. In case of oxygen, this is the exceptional case. In case of oxygen, you have to take double number. That means 6 valence electrons of sulfur minus 2 into bond pairs. Are you clear? 2 into bond pairs you have to take. Bond pairs 2. 2 into 2 means 4. 6 minus 4, 2 electrons. 2 electrons means 1. How many lone pairs? 1 lone pair. Clear? One lone pair, students. Only 1 lone pair. So here lone pair is present kada. Lone pair is present. Then according to the now hybridization, tell me. Hybridization means how to write? 2 plus bond pairs 2. Okay. Lone pairs how many, students? 2 electron. Lone pairs 1. This is bond pair. This is lone pair. 2 plus 1, 3. 3 means which hybridization, students? Sp2 hybridization. Okay. 3 means Sp2 hybridization, but shape is different because here 1 lone pair is there. According to the Vesper theory, valential electron pair repulsion theory, students, its shape is Sp2 hybridization. That shape is nana V shape. Okay, V shape we can write, or you can take angular, also correct. Next, nana bent shape. These 3 you can write, students. 3 also same only. Anyone, yeah, based on the options you can write. Okay, now 3 options same only. 3 shapes, so same only, students. I am taking the shape SO2, students. This is SO2. It is a band shape or angular shape or V shape. Here 1 lone pair is present. Here there is no lone pair, but it is having the lone pair. Are you clear? It is having 1 lone pair, students. Understood, Amma? So this is about the which hybridization, sp2 hybridization completed. Next example, see students, next one, sp2 over one lone pair is present, sp2 completed. Now sp3 hybridization example, I am taking methane, methane. Now tell me students, how many bond pairs are there? 4 bond pairs. How many lone pairs? Lone pairs how much students? Carbon valence electrons 4 minus bond pairs 4, total 0. No lone pairs. Are you clear? Lone pairs 0 students. Then hybridization, how to find it? Bond pairs plus lone pairs. This is the formula students. Okay, bond pairs plus lone pairs. So bond pairs, this is the formula, lone pairs to find it. Okay. Right. Now what is the hybridization? Bond pair plus lone pair. Bond pairs 4, 4 plus lone pairs 0. So 4 plus 0, 4. 4 means which hybridization students? I told you 4 means sp3 hybridization. Now write that one, sp3 hybridization. What is the shape? sp3 means here 0 kada, lone pairs absent kada. When lone pair is absent, what is the shape nana? sp3 hybridization, tetrahedral shape. Write that one, tetrahedral shape. Okay, tetrahedral shape. What is the shape nana? What is the geometry? Ch4 geometry, tetrahedral shape. This is the tetrahedral shape. Clear? This is the tetrahedral shape. Understood, amma? Okay. So this is sp3 hybridization completed, nana. Next one is next one students, ch4 completed. Next sp3 D hybrid, no, sp3 only is, lone pair is absent. Now I'm taking the one lone pair. If one lone pair is present, 2 lone pairs are there, 3 lone pairs are there. I'm taking the lone pairs example students, ch4 completed. Now I'm taking nh3 example, nh3. Okay. Now see Nana, NH3. Now NH3 example, how many bond pairs? 3. 3 hydrogens attached. How many lone pairs? Valence electrons minus bond pairs. That means nitrogen 5 valence electrons minus hydrogen bond pairs 3. 5 minus 3 means 2 electrons, means 1 lone pair. Clear? 1 lone pair. So that means 3 1. 3 1. Okay. Then 3 plus 1. How much students? 4. Means which hybridization? sp3 hybridization. Okay, 3 plus 1 sp3 hybridization students. Then what is the shape nana? Sp, but here lone pair is present. According to Vesper theory, its shape will be changed. sp3 shape kada, sp3 hybridization. What is the shape students? Trigonal pyramidal shape nana. Which shape students? Trigonal pyramidal shape. Trigonal pyramidal. So what is the geometry students? nh3 geometry nana. N, 1 lone pair, 3 bond pairs. Okay, 3 bond pair students. So this is about NH3 molecule. If 1 lone pair is present, same hybridization sp3, but here 0 lone pairs, 1 lone pair. Now I am going to discuss 2 lone pairs and 3 lone pairs also. Okay, if 2 lone pairs are there, sp3 hybridization only, 3 lone pairs are there. Now I am taking the which example students? That is which one? Next example. Example students, 2 lone pairs are there, suppose. So then what is the example we can take? Water molecule, you can take water. Okay, now in water students, how many bond pairs are there students? How many bond pairs? 2 bond pairs. Okay, bond pairs how many? 2. Next, how many lone pairs students? Lone pairs వచ్చేసి oxygen valence electrons 6. 6 minus bond pairs. 6 minus bond pairs means 6 minus 2. Are you clear? 6 minus 2 means 4 electrons, means 2 lone pairs. Are you clear? 2 lone pairs. What is the hybridization students? Hybridization, coming to the hybridization. Okay, hybridization. What is the hybridization? Bond pairs plus lone pairs. Formula bond pair plus lone pair. Bond pairs 2, lone pairs 2. Okay, then 2 plus 2, total 4. 4 means which hybridization? Sp3. What is the shape, Nana? Sp3. 2 lone pairs there. Sp3 hybridization shape is angular shape. Which shape? Angular shape. And coming to the geometry, students, what is the geometry? Angular shape. This which model? Water kadama? Water. So this is the water. H2O. Here 2 lone pairs are present. 2 lone pairs, 2 bond pairs. 2 bond pairs, 2 lone pairs. Clear? This is the this which shape, Nana? Angular shape, Nana. Now I am taking the example 3 lone pairs. If suppose 3 lone pairs are there, example we can take, Nana, 3 lone pairs are there. Then what we can take, students? 2 lone pairs there means angular shape. Okay, 2 lone pairs so angular, 3 lone pairs is there, 3 lone pairs are there. HF molecule we can take, none. Okay, HF molecule. How many bond pairs are there, students, in HF molecule? HF there. HF, how many bond pairs? Only one fluorine. Here only one you have to take. And how many lone pairs are there, students? How many lone pairs? Fluorine valence electrons, how many, students? Fluorine valence electron, 7th group element kada, 7 valence electrons. So 7 valence electrons means 7 minus 1, correct? 7 minus 1, 6 electrons means 3 lone pairs. Are you clear? 3 lone pairs are there. This is one bond pair. 3 lone pairs means only one hydrogen atom is attached to fluorine, one bond pair. And lone pairs, coming to lone pair, students, fluorine valence electron 7, 7 minus bond pair 1, 6 electrons means 3 lone pairs. Coming to the hybridization, Nana, bond pairs plus lone pairs 1 plus 3. This number 1 plus 3, total 4 means Sp3 hybridization. What is the shape, students? Lone pair is present. Then according to Vesper theory, what is the shape? Lone pair is there means linear shape, Nana. So what is the shape, students? HF molecule. This is the linear shape. Are you clear? Total 3 lone pairs will be there. 1, 2, 3. Like this you can take 3 lone pairs. Okay. Now till here Sp3 completed, students. Now Sp3 D hybridization, PCl5 example I am taking. Okay, PCl5. Now tell me, students, PCl5, how many bond pairs? 5 there. How 5 bond pairs? How many lone pairs, students? Phosphorus valence electrons 5, 5th group element, minus bond pairs 5 minus 5, 0 lone pairs. Then hybridization is equal to 5 plus 0, then 5 only. 5 means which hybridization? Sp3 D hybridization. Are you following, students? Hybridization 5 means Sp3D. Here starting only I gave you table now. This table you have to remember, students. Understanding? This table you have to remember. Okay. 5 means Sp3D, trigonal bipyramidal shape. Okay. Right. Now what is the shape, students? Trigonal bipyramidal shape. Okay. Right. Write that shape. Trigonal bipyramidal shape, Nana. Now coming to the geometry, students, trigonal bipyramidal shape, PCl5 kada, PCl5 example. So this is phosphorus, chlorine, chlorine, chlorine. Here one chlorine, here one chlorine. This is the PCl5, trigonal bipyramidal shape. Understood? So this is the PCl5 completed. This is Sp3D completed. 0 lone pairs. If 0 lone pairs means that is according to hybridization, that shape is fixed. And coming to the PCl5 after I am taking the SF4 example, students. SF4. How many fluorines attached? 4. That's a 4 bond pairs. How many lone pairs? Sulfur is the 6th group element, 6 valence electrons, minus bond pairs 4. 6 minus 2 means 2 electrons, 1 lone pair. If suppose 1 lone pair is there, now first you calculate hybridization. 4 plus 1, this 4, this 1, 4 plus 1, total 5 means which hybridization? Sp3D, 1 lone pair is there. Then what is the shape, students? Sp3D, what is the shape? Seesaw shape, Nana. Seesaw shape. Clear? What is seesaw shape, students? Here seesaw shape means SF4. F4. This is the seesaw shape. Here one lone pair is present. Clear? This is the seesaw shape nana. SF4 completed. Sp3 D hybridization completed, students. Now I am taking the if two lone pairs of electrons are there, Sp3 D only, two lone pairs are there. Two lone pairs means we can take example ICl3. Okay, I am taking the example, students, ICl3. Okay, ICl3. How many chlorines attached? 3 bond pairs. How many lone pairs, students? How many lone pairs are there? Tell me. How many lone pairs? Iodine is a which group element? 17th group element. 7th A, 7 valence electrons minus bond pairs 3. Total 4 electrons means 2 lone pairs. Are you clear? 2 lone pairs, students. Then what is the hybridization? 3 bond pairs, so 2 lone pairs. 3 plus 2, total 5. Means Sp3 D hybridization. Okay, 5 came. Now what is the shape? But here 2 lone pairs there. 2 lone pairs are there. Then what is the shape, students? T shape. What is the shape? T shape nana. T shape. How it is T shape, students? ICl3 kada. ICl. This is T shape. How many lone pairs? 2 lone pairs. Clear? So this is a 2 lone pairs. This is ICl3 Sp3D hybridization. Now I am giving the next example, students. Sp3D. If suppose 3 lone pairs are there. Okay, 3 lone pairs means what we can take example XeF2. I am taking example XeF2. Okay, XeF2. How many bond pairs, nana? How many bond pairs are there? 2 bond pairs. How many lone pairs? Xenon 8th A group element, 8 valence electrons, 8 minus 2, 6 electrons. So means 3 lone pairs. Then this bond pair, lone pair, how much, nana? 2 plus 3. Then you will get 5. 5 means which hybridization? Sp3D hybridization. 3 lone pairs having. Then what is the shape, students? 3 lone pairs there. Then shape is linear shape, students. Linear. Clear? Linear shape. Then what is the geometry, students? Linear means XeF2 kada. XeF2. Total 3 lone pairs. 1, 2, 3. Okay, total 3 lone pairs. XeF2 completed. Now Sp3 D2 hybridization, students. Sp3 D2. I am taking the example SF6. SF6. Now how many fluorines attached, students? 6 fluorines attached. So bond pair 6. How many valence electrons of sulfur? 6 valence electrons minus bond pair 0. No lone pairs. Now then this value add. 6 plus 0, 6 means Sp3 D2 hybridization. Sp3 D2 lone pair is absent. Then what is the shape, students? Octahedral shape. Octahedral SF6. Then octahedral shape, how it is, students? This is SF6 octahedral shape. Clear? This is SF6, students, octahedral shape completed. Okay. Now I am taking the Sp3 D2 hybridization. One lone pair is present. If suppose one lone pair, according to Vesper theory, what is the shape? I am taking the example IF5. Now see here, IF5 I am taking. IF5. Now how many bond pairs, students? IF5. How many bond pairs are there? Fluorine. 5 fluorines attached. That's a bond pairs 5. How many lone pairs? Iodine is the 17th group element. 7 valence electrons minus bond pairs 5. 7 minus 5 means 2 electrons. 1 lone pair. Okay, this 5 plus 1 add here. 5 plus 1, 6. 6 means Sp3 D2 hybridization. 1 lone pair is present. Then what is the shape, students? Square pyramidal shape. What is the shape? Square pyramidal shape. Then what is the structure? What is the geometry, nana? IF5 kada. IF5. F. Here one more F. Here one lone pair is present. Clear? So this is the which shape, students? Square pyramidal shape. Okay, square pyramidal shape. Now next one, Sp3 D2 only. If suppose 2 lone pairs are there, Sp3 D2, then what is the example, students? Okay, now see here, XeF4 I am taking. XeF4. How many fluorines attached, students? How many fluorines attached here? 4. That's a bond pairs 4. How many lone pairs? Xenon 8th group element. 8 minus 4. 4 electrons means 2 lone pairs. Then 4 plus 2, how much? 6. So 6 means which hybridization, students? Sp3 D2 hybridization. But here this 2 lone pairs, 4 bond pairs are there. Then what is the shape, students? Square planar. What is the shape? Square planar. Okay, XeF4. Then what is the shape? XeF4 kada. So this is the square planar shape, nana. Square planar. How many lone pairs, students? 2 lone pairs. Clear? 2 lone pairs, 4 bond pairs. 1, 2, 3, 4. 4 bond pairs are there. Clear? So this is the Sp3 D2 hybridization. Now I am going to discuss the Sp3 D3 hybridization model, students. IF7 I am taking the example. IF7. How many fluorines attached? 7 bond pairs. Now coming to the lone pairs, iodine is the 17th group element. 7 minus 7, 0 lone pair. 7 plus 0, that is equal to 7. Sp3 D3 hybridization. Sp3 D3 hybridization is pentagonal bipyramidal shape. Pentagonal bipyramidal shape. Okay, pentagonal bipyramidal shape. Now see here, IF7 kadama. IF7. So here F, here F, here F, here F, here F. Okay, now like this. Up, down. This is the pentagonal bipyramidal shape, nana. Okay, now last one is Sp3 D3. If suppose one lone pair is there, here 0 lone pairs. If suppose one lone pair is present, okay, example I am taking, students, XeF6 I am taking, XeF6. Now how many fluorines attached? 6 bond pairs. How many valence electrons? Xenon is a group element. 8 minus 6, 2 electrons means 1 lone pair. 1 lone pair is present. Now this 6 plus 1, 6 plus 1, 7 means Sp3 D3 hybridization. Shape is distorted pentagonal bipyramidal shape. Distorted pentagonal bipyramidal shape. Okay, distorted pentagonal bipyramidal shape, students. That means this is the shape, students. XeF6. Clear? Now see here, XeF6 shape. This is F, F, here F, here F, here F. Here one more F. One lone pair is present here. Okay. So this is about the students shape and geometry, everything I discussed you. Okay, now how to find, see here madam, this all, how to remember this all shapes. So okay, if suppose lone pair is absent, if lone pair is present. Now see students, one okay, I will give you the small trick, students, here. Okay, in the next video I will give you the trick, students, please. Okay, already this video is lengthy. Okay, to remember, how to remember easily geometry, the shape of the molecules, I will give the best trick. You can easily remember that trick. Here all the models I discussed you, students. If 0 lone pair, 1 lone pair, 2 lone pairs, what are the shapes? These are the shapes, students. Just you practice this table, you can easily answer any type of question, students. Okay, Nama? Okay, so these shapes are fixed, students. I hope you like this video, students. If you like this video, please like, share, comment and subscribe my channel, students. Thank you very much, students.